On the 23rd of July, 2025, a small team from the Freshwater Biological Association waded into the River Kent in Cumbria and began lowering mesh trays of mussels onto the riverbed. Each shell was marked with an individual vinyl tag, and each had been raised in captivity for 8 years. The shell that settled on the riverbed that day was the 5,000th since the program began, the result of 18 years of work. 5,000th marked a milestone, but it was also a step in a much longer story. Before it started, fewer than 10 living mussels remained in the entire river. Then the first trays went down, and the river responded. Silt stirred back to life, the water ran clearer, and fish returned to stretches where they had not been seen for years. All because the mussel simply existed. But 5,000 shells in the water is only a beginning. This is a story about how England tried to save a species that most people have never seen, about what it took, what nearly stopped the program, and why the outcome turned out to be more complicated than a victory. The freshwater pearl mussel, Margaritifera, lost more than 90% of its population over the course of the 20th century. That is a Europe-wide figure. Rivers where mussels once covered the riverbed in several layers now hold only scattered individuals, or none at all. In England, the picture is worse than the continental average. It is believed that England today supports only one naturally reproducing population. One river in the entire country where mussels successfully reproduce without human intervention. All other populations are what biologists call non-recruiting populations. The adults are alive, but juvenile individuals do not survive. And here is where the numbers become genuinely uncomfortable. Cumbria holds more than 90% of England's freshwater pearl mussel population, and that alone speaks to how catastrophic the national picture is. The last stronghold of an entire country is concentrated in one corner of one county. The River Kent, which rises in the Lake District, flows through Kendal and empties into Morecambe Bay, is a special area of conservation, designated precisely because it was supposed to be one of those final strongholds. But the population fell off a cliff. Fewer than 10 individuals. The causes are familiar from almost every story of freshwater ecosystem collapse. Agricultural runoff raising nitrogen and phosphorus levels in the water, silt from disturbed land clogging river gravel, declining populations of salmon and trout, and historical pearl harvesting. Pollution and overexploitation are considered the primary drivers of decline in England and Wales. It is a systemic failure that accumulated over time. Here's the American parallel that fits most precisely. Take the ELWHA River in Washington state. 2 hydroelectric dams were built on the Elwha in the early 1900s, and for over a century they blocked migratory fish from accessing more than 90% of the watershed. When those dams were removed between 2011 and 2014, scientists did not simply press a button and declare victory. The river had to be rebuilt, with sediment, vegetation, and fish populations recovered piece by piece. The situation on the Kent is structurally similar, but without dams. The damage accumulated more slowly and quietly. You cannot restore one species in isolation from the system it lives in. The difference with the Kent is that repairing the system and restoring the species had to happen simultaneously. There was no possibility of waiting for one to finish before beginning the other. That logic was built into the foundation of a program that launched in 2007, not because conditions were ready, but because the population could no longer wait. The Freshwater Pearl Mussel Ark was established in 2007 with funding from Natural England and the Environment Agency. The aim was to breed freshwater pearl mussels from priority English populations and to release juvenile individuals back into the rivers their parents came from. The basic idea sounds straightforward. Take mussels from an aging population, breed them under controlled conditions, raise the juveniles to a size where they can survive, then return them. But the life cycle of this species makes that notion impossible. The freshwater pearl mussel begins life as a tiny larva, 0.6 to 0.7 millimeters long, which an adult mussel expels into the water alongside a mass of 1 to 4 million other larvae. This release happens within just 1 or 2 days, sometime between July and September, and then they have to find a fish. This is where the program almost fell apart before the first release. Pearl mussels use wild brown trout and Atlantic salmon as hosts. The relationship is symbiotic, The fish provides a necessary stage in the mussel's life cycle, while the mussels improve water quality by filtering it. The glochidia attached to the gills of a young salmon or trout spend roughly 9 months there developing, and then drop off onto clean river gravel and begin the slow process of growing to adulthood. The freshwater pearl mussel needs 6 to 9 years to reach a size sufficient for release into the wild. That is 6 to 9 years in a controlled environment before a single animal enters the river. This is not a fast program. After 6 to 9 years, people came forward and said, "Do not release them yet." The opposition to releasing mussels into the Kent before full habitat restoration rested on a reasoned position. The argument ran like this: water quality is still borderline. Juvenile individuals are the most vulnerable stage. If we release them now, before sediment loading has been reduced and nutrient levels have stabilized, they will die. We will burn through animals we spent nearly a decade raising. And the skeptics, as it turned out, were right, but not about what they thought. That argument had scientific backing. From October 2024 through to summer 2025, the Freshwater Biological Association ran tests placing juvenile mussels into temporary holding devices, so-called mussel silos, at 3 sites on the River Kent, to establish whether water quality there was sufficient for survival and growth of juveniles before a full release began. The skeptics were not wrong about the risk. They were right that the environment was not ideal. What they did not account for was what happens to a population of fewer than 10 individuals while you wait for perfect conditions that may never fully arrive. LaVictorie, who has led this program from the first day, described the whole process simply: "It has been a very, very long road. 18 years, and not one release happened under ideal conditions. At any given moment, the Ark holds around 50,000 freshwater pearl mussels, but the majority are very small because they grow so slowly." The facility is located on the shores of Windermere in the Lake District, where the Freshwater Biological Association has been conducting research since 1929. The Kent was not the first river the program turned its attention to. The pilot project was the River Irt, also in Cumbria, the place where the team developed the methodology. The Irt's population once numbered tens or hundreds of thousands of individuals, but had contracted to around 300 aging mussels. It was the testing ground. In 2021 and 2023, juvenile mussels from several age cohorts were released at 4 sites on the Irt. The released individuals were 6 to 9 years old, with shells of more than 15 millimeters at the time of release. Each was individually tagged with vinyl and PIT tags, the same technology used to mark livestock, so that monitoring could track every animal separately. Then came the Kent. Under the R4Ever Kent project, funded by the EU through the LIFE program, a return of 4,000 mussels over the coming years is planned to pull this population back from the edge of extinction. The July 2025 release, the 5,000th animal in the entire ARK program, marked a threshold that saw the Kent move from observation site to active intervention. The release process itself looks simpler than it sounds. Before each mussel reaches the river, it is run through a flume system, an artificial current, so that an animal that has spent 8 years in an aquarium with a steady flow does not die of shock on first contact with real river water. Then the mussel is placed by hand between stones onto a specific patch of gravel riverbed. No cages, no protective structures, just a palm and a substrate. And this is where the hardest part begins for the team. Almost immediately after placement, the mussels disappear. Current and shifting gravel move them from where they were placed. They do not walk away on their own. The water carries them. Exactly where they end up is unknown. A juvenile mussel the size of a coin buries itself deep in the substrate, and seeing it there is nearly impossible. For months, the team does not know with certainty how many are alive. Monitoring proceeds by tags, but a tag can only be read if the animal is within range of the scanner. But here is an important fact that needs to be understood. In most populations, the oldest individuals are more than 80 years old because juvenile mussels cannot survive in degraded conditions. In some rivers, the youngest mussel is older than 80. The population is not being replenished at all, zero recruitment. It does not shrink visibly year on year because adults live to 130 years, but it is moving toward extinction with the precision that can be calculated. Count the adults, estimate their age, work out how many years remain before the last one dies. The freshwater pearl mussel lives to 130 years in the wild. In some populations, up to 280 have been recorded. Even taking the lower figure, there are rivers where the animals currently lying on the riverbed were juveniles before the United States existed. They are the last of their generation. After them, no one. That is what quietly moving toward extinction means for this species. The July 2025 release raised the population in the River Kent from fewer than 10 individuals to more than 100. By any count, a tenfold increase. The program worked in the narrow sense. The mussels went in, the number grew. But here's what the scientists running the program carefully clarify. An increase in number is not the same thing as population recovery. The animals placed in the Kent on the 23rd of July are juvenile individuals. They were raised under controlled conditions. They can filter water. Each adult mussel filters around 50 liters a day, improving river water quality and increasing the survival chances of salmon and trout eggs and fry. But these juvenile individuals have not yet survived a Cumbrian winter in a river with variable sediment loading and seasonal runoff from upland farms. They have not yet passed through the gill stage on wild fish in an uncontrolled environment. They have not yet reproduced. The freshwater pearl mussel does not reach sexual maturity until 12 to 15 years of age, or at a shell length of roughly 65 millimeters. The animals released in 2025 are 6 to 9 years old. The earliest any of them could reproduce is 2031 or 2032, and that is contingent on them surviving, on water quality being maintained, on salmon and trout populations being sufficient to receive the next generation of larvae, and on the gravel substrate remaining clean enough for juvenile settlement. LaVictorie explained it this way: the breeding program buys the time needed for the complex work of habitat improvement. And without that time, river recovery simply cannot keep pace. Buys us time. That is the real purpose of the release program. But there is a detail that most reports on this release missed. Not one of the mussels released on the 23rd of July can yet reproduce, and none will be able to, at the earliest, until 2031. This is not a footnote, it is the actual substance of the event. 100 individuals in the river is not a recovered population, it is a deposit, proof that the river can receive them. Whether it can hold them is what the next decade will show. The unexpected outcome of the Kent intervention is not a failure. The 5,000th mussel did not mark the end of something. It marked the moment when the space between possible and impossible widened slightly. Whether the Kent population eventually moves from augmented to self-sustaining depends on whether the habitat restoration work can catch up with the species restoration work. And that is a different program, moving on different timelines, with different funding and no guarantee the two will converge. Many English rivers today hold only isolated individuals with no recorded juveniles. Such populations can disappear through the absence of recruitment. The Kent now has more than 100 individuals. That is a real difference. But consider the rivers where there is no ARC, no life funding, no project officer with a mesh tray in the water. Those populations are aging on the same clock. The youngest individual in some of them is 70 years old. The mathematics does not change because no one is watching. Although the freshwater pearl mussel is the primary target species, interventions in the habitats of the Eden, Derwent, and Kent simultaneously benefit the European eel, Atlantic salmon, brown trout, river lamprey, and otter. That is how keystone species work. Restore the conditions for the most vulnerable animal in an ecosystem, and everything else that shares those conditions receives the same benefit. Is habitat restoration alone, tree planting, sediment fencing, changes in farming practice sufficient to trigger natural recruitment from a handful of surviving adults? This has not been tested at scale in England. There is one river where it may still be possible to find out, and the population there is aging.